In this lesson, we're going to discuss like terms, but we're going to pay particular attention to why you can add particular terms, but there are other terms that just don't add together nicely. When we're talking about like terms, I want to basically explain to you why you can add something like 3x plus 4x to make 7x. So here we're just saying that 3x plus 4x is the same thing as 7x. However, despite the fact that you can add 3x and 4x, if this x was some other letter, like y, you can't actually add them together. And in an even more surprising twist, you can't even add 3x and 3x squared together. Now, in most math classes, you're going to be told this fact, and then you're going to be told these two don't add, and you'll be on your way. You do some questions and everything will be fine. But that just didn't satisfy me when I was told it. I mean, why can I add these two in the first place? What's so special about 3x plus 4x that allows me to add them to make 7x? But then 3x plus 2y or 3x plus 4x squared, we just can't simplify that at all. Why not? Well, to explain this to you, I'm going to call this the Gluing Theorem. And then I'll explain to you by analogy why I've called it the Gluing Theorem. Now, whenever you're stuck on any problem to do with algebra, you should always try thinking of the problem without any pronumerals. So that's where I'm going to start. I'm going to start by showing you an example where we don't have any pronumerals. Okay, so here's the question. We're asking whether we can simplify 3 times 5 plus 4 times 5. Well, we know that we can draw 3 times 5 as a rectangle, where one side is 3 and the other side is 5. And then after this, we can also draw 4 times 5 with another rectangle, where one side is 4 units wide and the other is also 5. Okay, so now you're ready to understand why I've actually called this the Gluing Theorem. The idea is that this side over here is 5, and this side over here is also 5. So why don't we just go ahead and glue this side directly to this side to make a single shape? Okay, so my picture is definitely not perfect here. But you can see that this side over here is still 5, because this was 5. And then this side over here is 3, and this side over here is 4. So then we can just say that this is going to be 3 plus 4, or 7. So in a sense, it looks like we're multiplying a block whose height is 5 and whose width is 3 plus 4. And actually, this is the general idea. If this height over here was not 5, let's pretend for a moment that we crossed off, say, 2 of the squares, so that the new height is 3. If this height was 3 and this height was 3, then this height is going to be the wrong height for this, and they won't stick together nicely. So you actually need these numbers to be exactly the same, otherwise you actually cannot glue them together. And this immediately explains why, if this 5 were, say, a 7 or something, you would not be able to glue these two shapes together, because they're not what we'd call like terms. And in fact, this is the exact argument we would repeat for the general case. Now, to make the general argument, I'm going to replace every instance of a 5 in this diagram for an x. Now, I don't actually need to change the picture. Despite the fact that I have 5 blocks stacked on top of each other, x is just a placeholder for any number, and x could be 5 for all we care. But it could basically be anything else you wanted. But despite that, 3x is the same thing as 3 times x, so you've got yourself a block that looks like this. And 4x is just the same thing as 4 times x, so you have this block again. We can add them together to make this block over here, and its height is just going to be x, and its width is going to be 7. And now because the width is 7, then we know that 7 times x is the same thing as 7x. And that explains perfectly why 3x plus 4x must be the exact same thing as 7x. So, in general, we could repeat this on this diagram here. Let's suppose these heights over here are x, and these heights over here are actually y. Then after this, I could just label this A, B, C, and D, because they could be basically any number you wanted. Now, this rectangle over here is A times x, or AX. This rectangle is B times y, or BY, and then this is CX, and this is DY. Now therefore, we can basically say that these 4 shapes represent AX plus BY plus CX plus DY. We're basically adding the blocks from each of these individual areas. Now, just like we saw in our example over here, 3x plus 4x can add together to make 7x, so you can add ax and cx together by gluing this side to this side. But I think you can see, just by looking at the picture, that if x and y are not going to be the same height, then you can't glue them together to make a perfect new area. You won't really get a rectangle anymore if you try this. So that means we can go ahead and take these four shapes, and then glue these two together, and then glue these two together as well. Now, because we've glued these two shapes together, this height over here is going to be x, because that's what it originally was. But then you have a here, and then you have c here. This is a, and this is c. So that means this whole length over here is going to be a plus c. And then the same thing goes for these other shapes. The height is still going to be y, but this is b plus d. So this whole length is b plus d. And therefore, after we've glued these four shapes together to make these two shapes, we can say that ax plus by plus cx plus dy, which is written over here, is the exact same thing as x times a plus c plus y times b plus d. Now, since this term and this term both have an x in them, you can sort of think of it like you're taking out a common factor of x. That's why a lot of people call this factoring out the common factor. However, in my head, I always imagine this like you're taking two rectangles and gluing them together to make a single, larger rectangle. If I'm going to be completely honest, it doesn't even have to be larger because these numbers can actually be negative if they want to be. But we'll cover that in an example later on, as you'll see. Okay, so now that we've dealt with this case, let's move the example that I showed you away, and then we'll deal with the other case that we haven't considered yet. Okay, so we now know why you can't add 3x and 2y together. It's because they don't have the same height. So then this begs the question, why can't we add 3x and 4x squared together? Well, again, I'm going to explain this by an analogy. In this case, I've given two examples. I want to see whether we can simplify 3 times 5 plus 4 times 6. And then I want to see whether we can simplify 3 times 5 plus 4 times 25. I'm going to start with the one on the left first. So let me start by drawing it out. So in this particular case, we could try gluing this side to this side, but the problem is that we'd have one left over, and we wouldn't be making a new rectangle. So because of this, we can just say that we can't actually simplify 3 times 5 plus 4 times 6. I think you knew that already, but it's going to be important for the next case. Now, the next case is actually really similar. I've asked, what about 3 times 5 plus 4 times 25? Now, 25 is the exact same thing as 5 squared. So in this case, I'm asking, what about 3 times 5 plus 4 times 5 squared? Okay, so I probably don't need to draw this for you, but I'm going to do it anyway. So on the left, we have a block that's 3 wide and 5 high. On the right, we have one that's 4 wide and 5 squared high. Well, I think you can immediately see, just by looking at this, that we cannot glue this side to this side. They're just not the same size. So just like we saw in the last case, we can't glue 3x to 4x squared because x is not going to be the same size as x squared in general. So this immediately tells us that we can glue x squared terms to other x squared terms, but we cannot glue x terms to x squared terms. So I'm going to draw another picture just to illustrate this. So I want you to imagine that this height over here is x, and that this height over here is going to be x squared. And again, I'll just randomly set the widths here. I'll set this to a, b, c, and d, just like I did last time. Well, we know that this height over here and this height over here are exactly the same. Then we can also say that this height and this height are also exactly the same. So we can glue them together to make a single shape. Now, this height over here is still x squared, but then this width is just going to be a plus c. This height over here is going to be x, but then this width is going to be b plus d. Now, this shape over here has an area of a times x squared. This one is b times x, this is c times x squared, and this is dx. And therefore we can say that ax squared plus bx plus cx squared plus dx is the exact same thing as x squared times a plus c plus x times b plus d. So I think we're actually done with this example on the left, so let's get rid of it. Okay, so the first thing I want to note is, it doesn't really matter whether we write the thing on the left or on the right, because we know that 3 times 4 is the same thing as 4 times 3, so you can always swap the order of these two things and the answer won't actually change. And the other thing I need to say is, You can only glue things together if you're absolutely sure that they have at least one side in common. And this immediately explains why you can glue 3x plus 4x to make 7x, but you can't glue 3x plus 2y, and you definitely can't glue 3x plus 4x squared. So let's combine everything we've learned so far. I'm going to give you an example that combines both of these cases. Okay, so I've written a pretty big expression here, but let's say we wanted to simplify it. I've got 3x plus 2y squared minus 4x plus 7x minus 4y squared plus 2y. This is way too long. We can simplify it pretty easily just by imagining the boxes that represent all of these terms. Okay, so in this example, I'm not actually going to bother drawing on the individual grids for each of these. I don't even know how many grids I should put down for x anyway. Remember, the whole idea of having something like x or y is to allow this expression to work for absolutely any value of x or y that you'd like to choose. However, in the cases where we have negative numbers, like we do for 4x and minus 4y squared, I'm going to draw the boxes with an arrow on them, and you'll see why in just a moment. So I've drawn each term one by one here, and for each term that's positive, I've drawn the arrow pointing to the right. And if the term's negative, the arrow is pointing to the left. This indicates the idea that positive arrows and negative arrows cancel each other out. In general, you don't need to draw out the boxes like this every single time. I'm just doing it in this particular case to help you understand what's going on. Once you get the general gist of things, you don't really need to draw them anymore. In this case, I'm going to glue all of the x's together. And then I'm also going to glue these y squareds together, and then this y doesn't really have anything to glue to, so I'm going to leave it alone. Also, you should be a little bit careful here. Notice that this 2 moves to the right by 2, but then we move left by 4. This is going to be quite important, as you'll see when I actually glue things together. Okay, so we can see in this case that we've gone to the right by 3, then we've gone to the right by 7 more, but then we've gone left by 4. This is the same thing as going 3 plus 7 and then subtracting 4. So you've gone 6 to the right in total. In this next case, we started here, we went right by 2, and then we came back by 4. That's the same thing as just going left by 2. And then for the last one, we just copied it out, so nothing really changed there. So therefore in this case, we can see that 3x plus 2y squared minus 4x plus 7x minus 4y squared plus 2y is the same thing as 6x minus 2y squared plus 2y. But the way I'd actually expect you to do this is to avoid the boxes altogether. So let me show you how I'd do this if we didn't want to draw any pictures. Okay, so for starters, I'm going to grab each of the terms with an x and bring them together. Then all the terms of the y can stay together, and all the terms of the y squared can stay together. Now you can see that all three of these terms have an x in front of them. And that means I can take the x out as a common factor. So that means we can move it out to the front of all three of these terms and multiply them. And now we can do the exact same thing for y squared. We can just take y squared out the front because it's a common factor. Now after this, we can just realize that 3 minus 4 is just minus 1, plus 7 is 6. So we get x times 6, which is what we had before. And then after this, we can say that 2 minus 4 is the exact same thing as negative 2. So we can replace that as well. Now at this point, we've arrived at the answer, but let's just write it in a more traditional form. Usually we like to write numbers first, and we don't like to write the multiplication symbols. And the same goes for this. Instead of writing plus y squared times minus 2, we just write it as minus 2y squared. And this all agrees perfectly with our picture here. Notice that we have 1, 2, 3, 4, 5, 6 terms, and that corresponds to 6 boxes over here. In the final answer, we only have 3 terms, and that corresponds to the 3 boxes we were left with after gluing some boxes together. So that means we can simplify this whole expression over here into this really simple expression, which is just 6x minus 2y squared plus 2y. And I think that just about completes our example. Okay, so I'd just like to summarize this lesson before saying goodbye for the day. In this lesson, we learned that you can add 3x and 4x together to make 7x. But if you try adding 3x plus 2y, or 3x plus 4x squared, you cannot simplify them. Now, the reason you can't simplify them is because you can't actually glue them together. We said that you can only add things together if they have a common side, and that allows you to glue them together to make a single object as we've shown here. This means that you can glue things where you have an x on one side and an x on another, or a y on one side and a y on another. You can even glue an x squared to another x squared, and that works just fine. Now, it is possible to always draw out the boxes like this and glue the sides together. That will always work. But I seriously advise against it. You really shouldn't be drawing these boxes all the time. Maybe while you're starting it's okay, but eventually you should learn how to do this completely algebraically, like we've got here and over here. In the future, some of the problems you're going to have to solve are going to have so many steps if you're going to keep drawing out these individual boxes every time you try to add like terms. But certainly, you should always be thinking about these boxes anytime you are adding together any like terms. Now that just about completes everything I wanted to say in this lesson. Later on you'll see that like terms are an incredibly important part of building up algebra. In the future, I'm sure that you'll be able to do like terms without even really needing to bat an eye. But I'm sure you'll see that as you continue your studies of mathematics. So there, I'd just like to complete our lesson on like terms. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.